Okay, here are the answers to the closure activity or the study guide. Problems 1 through 3, it says state that the given functions are inverses. So all I did to do these problems was to plug a number in for the first one and then plug the answer and see if I got my original number. So for g of x, I plugged in 2. So I got 4 minus 3 over 2 times 2, or 4 minus 3, which is 1. And then I plugged 1 in for f of x. So I got 1/2 times 1 plus 3 over 2, or 1/2 plus 3 over 2, which is 4 over 2, or 2, which is the original number I plugged in. So the answer is yes, they're inverses. Problem number 2, I plugged in 1 to the first one and got negative 12 minus 2 times 1 over 3. So I got negative 12 minus negative 14 thirds. So then I plugged it into the second one. So I got negative 5 plus 6 times negative 14 thirds divided by 5. So I got negative 5 plus negative 28 divided by 5. So negative 5 plus negative 28 is going to give me negative 33. Negative 33 divided by 5 is not equal to 1. So the answer is no. For the last one, I plugged in 0. So negative 16 plus 0 divided by 4 equals negative 16 fourths, which is negative 4. So then I did 4 times negative 4 plus 16. Negative 16 plus 16, which is 0. So I got my original number, so the answer is yes. Problem 4 through 6, we are finding the inverses. So I replaced, switched x and y. So x is going to equal the cube root of y minus 3. So I added 3 to both sides. Equals the cube root of y. So I cubed both sides. So h to the negative 1 of x is equal to x plus 3 cubed. For 5, I did the same thing. So I got x equals 2y cubed plus 3. So I subtracted 3 from both sides. Divided both sides by 2. And then I took the cube root of all of both sides. So h to the negative 1 of x equals the cube root of x minus 3 over 2, where the whole thing is underneath the cube root. And then problem number 6, x equals 7y plus 18 over 2. I multiply both sides by 2. 2x equals 7y plus 18. Subtracted 18 from both sides. 2x minus 18 equals 7y. So I divided both sides by 7. So g to the negative 1, or inverse of x, equals 2x minus 18 over 7. For problems 7 and 8, I'm going to find the inverse of each function and then graph the function of its inverse. So I did it algebraically. I replaced just like in the above problems. X would equal negative 2y cubed plus 1. I subtracted 1 from both sides. Divided both sides by negative 2. Then I took the cube root. So I ended up with my new function being, I'm going to move everything up a little bit. So f to the negative 1 of x equaled the cube root of x minus 1 over negative 2. So then I was supposed to graph both of them. So I did an x and y table, and then I just made the inverse of my x and y table. So I plugged in negative 2 and got negative 15. -1 and got 3, 0 and got 1, 1 got -1, 2 got -15. So I graphed, so -1 was +3, 0 was +1, -1. So I know it's a cubic, so it's going to look like this. So then I'm going to change colors when I do the other one. So I'm going to flip it. So 3, -1, 1, 0, and -1, 1. So it's going to look like, this will look like this. So problem g of x. So I got the inverse of it, and I'm just going to write it was -1 of x. It was 3x plus 5 divided by -1. So I rewrote it as -3x minus 5. So when I graphed them, I got my xy table. Was -2, -1, 1, -2. So then -1, -2, -2, 1. So this one, so -2, -1, and 1, -2. That would be one of my graphs. And then the other one was -1, -2, -2, 1. So the other graph would look like that. Problem 9 through 16. I just have to rewrite the logarithms as exponential and vice versa. So I'm not actually solving anything. I'm just rewriting it. So this first one, 4 is the exponent. So it's 4 to the y equals x. This one is 2 to the third equals x. 5 to the x equals 30. The log of 4 of 80 equals x. The log of 1/2 of 64 equals x. The log of x of 343 equals 3. The x to the y equals 32. And x to the -4 equals 1 over 16. So the next problem, it's having you evaluate them. So you want to try to do this without a calculator, but you could use your calculator if you ended up needing to. So first I'm going to change any logarithm into an exponent to see if I can do it that way. So I get 5 to the 4th equals x. So then I get x equals 625. For this one, it's 9 squared equals x. So x is going to be 81. That's what I can change to a logarithm. It's the log of 1/3 of 243 equals x. And then you end up with x equals -5. The log of 6 of 7776 equals x. And x ends up equaling 5. So 7 to the x equals 1 over 49. So you could change it to a logarithm, but I know 7 squared is 49. So x has to equal -1/2, or -2, sorry. So 2 to the x equals 32. So x has to be 5. 11 to the third equals x. So x is 1,331. And 5 to the x equals 125. So I know that x to the third equals 125, so x has to equal -3. these problems we're solving. So you got to make sure to use your calculator. So the first thing that you're going to do is you're going to rewrite it as a logarithm. And this one you can just plug right in and you get x equals 2.34. Problem 26, I have to divide by 5 first. So I get the log of 3.14 or 18/5 equals x. And then when I put it in my calculator, I got x to equal about 1.112. 1.12. For 27, first I have to subtract 7 from both sides. So I get 6.5 to the x equals 14. And then divide both sides by 2 and get 6.5 to the x equals 7. So then I do the log 6.5 of 7 equals x. When I put in my calculator, I get x to be 1.04. For this one, I'm going to subtract 6 from both sides first. So we get negative 1/2, 14 to the x equals negative 15.1. Multiply by negative 2. So I'm going to get 14 to the x equals 30.2. So it's the log of 14 of 30.2 equals x. So x equals 1.29. Okay, so 29 had me matching the systems. So to do this, I actually didn't solve the systems completely. I just solved for one of the variables, and then I used it to figure out which one matched. So for the first one, I took the negative x plus 5y. I took this one and this one, and I added them together. And when I did that, the x's canceled out, the y's canceled out, and I got negative 6z equals negative 18. So z ended up equaling 3. So then I looked for the one that had 3 as z in it, and there's only one of them, so it had to be this one that matches. For the next one, I combined the negative 2x minus 5y and the negative 2x. So when I combined, I got a negative 4x. The y's canceled, the z's canceled, equals 16 divided by negative 4. So I got x equals negative 4. Well, there's only one that x equals negative 4 for, so this one had to match. For the next one, I combined let's see, yeah, negative 3x. Oh, sorry. So first I combine these two. So I got a negative 3x, y's canceled, plus 2z equals negative 5. Then I combined the negative x and these two. So I ended up with x minus 2z equaled 7. So then I could combine those two, and I got negative 2x equals 2 divided by negative 2. So I ended up with x equals negative 1. So it had to be this one. So for the next one, it looks like I combined these two first. So I got 2x plus 2z equals 24. Sorry, 6x. And then I combined these two. So I got 9x, the y's canceled out, minus 4z equal 36. So this one took a little bit more time because there's a little more steps. So then I multiplied the top by 2 to get the z's to cancel out. So I got 12x plus 4z equals 48. And 9x minus 4z equals 36. Combine those, I ended up with 21x equals 84. So I got x equals 4. So that gave me this one right here. To match to that one. So for this next one, I noticed that the top two will cancel. So I'm going to get r, the s is minus 7s equals negative 20. And then I'm going to combine so first, it looks like I multiply, I want to combine. So I combine those two first, and then I can combine, I'm looking to get rid of the t's. So I can multiply this one by 2 and get 8r plus 2s minus 4t equals 10. 8r plus 2s minus 4t plus 10. So when I combine, I'm going to end up with 12r minus 2s equals 6. So I'm going to multiply the top one by negative 12 and get negative 12r plus 84s equals 240. Bottom's going to say 12r minus 2s equals 6. So when I combine those together, I'm going to get 82s equals 246. And when I divide, I'm going to get s equals 3. So since it's RST, I'm looking for one that has a 3 in the middle, which happens to be that one. So this one has to be my match. And then the last one, due to process of elimination, has to match the last one. So these problems take a long time, so keep in mind that there's only a couple of them on the test, but you want to make sure that you know how to solve for all 3 variables. So that's what the next set of problems were. So the next set of problems, we are solving for all 3 variables. So we have to combine some in order to get it. So for the first one, I have 3x minus 2y plus z equals 3. 5x plus y plus 2z equals 8. Negative 3x minus y plus 3z equals negative 22. So I decided to cancel out the y's first. And the reason I did that is because these two already are going to let me cancel out y by adding them together. So if I add those two together, I get 2x. The y's cancel, plus 5z equals a negative 14. So then I want to cancel out the y's in the top one. So if I multiply this one by 2, I can get 10x plus 2y plus 4z equals 16. And then when I add those together, I'm going to get 13x. The y's cancel out. I get 5z equals 19. So the next thing I did was I multiplied the top one by -2. So I got to get rid of, and I'm not going to do all of these. I'm just going to do this first one, and then I'll just give you the answers to the other ones. So the top one I multiplied by a -1 to get rid of, so I can cancel out the z's. So I'd get -2x minus 5z equals 14. 13x plus 5z equals 19. So I combine those together. And when I do that, I'm going to get 11x equals 33. Divide 11, divide 11. So I'm going to get x equals 3. So then I'm going to plug it back in to solve for z. So I'm going to plug it into the first one. So I get 6 plus 5z equals -14. Subtract 6. 5z is going to equal -20. So z is going to give me -4. So then I plug it back into any of the top ones. So I'm going to do it to the first one. So I'm going to plug it into, so the z, so I get 9 minus 2y minus 4 equals 3. So 9 minus 4 is 5. So I get -2y plus 5 equals 3 minus 5. I get -2y equals -2. So y is going to equal 1. So all of these are done exactly the same way. So in this particular case, my answer is 3, 1, -4. For the next ones, like I said, I'm not going to go through each one. I'm just going to give you the answer so you can check your solutions. It's 31, you should have gotten -7, 2, and 1. For 32, you should have gotten 3, 1, and 2.5. For 33 was no solution because they canceled out and did not equal each other. 34, the correct answer was 36, 24, and 12. And actually the first thing I did in these is I got rid of the denominator. So I multiplied by 6, 12 for each one and gave me no denominators. And then 35, the answer is all real numbers. Problem 36 through 40, I am performing the indicated operation. So remember to add, I have to find a common denominator. So I would multiply this one by n plus 1, this one by n minus 7. So I'm going to get 7n squared minus 49n plus 8n plus 8 over n plus 1 times n plus 7. Combine like terms, I'm going to get 7n squared minus 41n plus 8. And that's actually my answer. For b, I'm going to do the same thing. Multiply this one by b minus 8 and this one times b plus 3. So I'm going to get 3b plus 9 plus 7b minus 56. So I'm going to get 10b minus 47. That's my answer. Problem 38, I am multiplying. So the first thing that I can do is cross reduce. So the 6's both cancel, the r plus 2's cancel, and 4 goes into 25 times. So my answer is just r over 5. 39, I have to multiply by n minus 5 and 3n minus 8. So I'm going to get 9n minus 24 plus 6n minus 30 over n minus 5 times 3n minus 8. So I simplify and I get 15n minus 54 over n minus 5 times 3n minus 8. Problem 40. it is a multiplication problem. So the first thing I'm going to do is factor. So the top factors to x minus 5, x minus 5. The bottom I can pull a 10 out of to get x minus 10 times x minus 10. So the bottom of the next one's a little tricky because it's got a negative in it. So I can actually pull out a negative sign, which is going to make it a positive x minus 5. So then I can simplify x minus 5 and x minus 5, x minus 10 and x minus 10. So I get x minus 5 over negative 90. 41, I'm going to factor it as well as flip it. So I get a minus 4 over a minus 4a plus 2 times a minus 5 over 1. So these cancel. My final answer is a minus 5 over a plus 2.